Hello and welcome to another How to Code Well web chat. My name is Peter Fisher. This morning I want to talk about password storage and website security in general. Now, this is an ongoing challenge for us web developers because obviously we store our passwords in a hashed kind of manner against perhaps a database or some form of storage. We obviously don't save the clear text password anywhere just in case the database gets compromised. The challenge, though, is with enhances and improvements to hardware. The hackers, the people who are using the web maliciously, who break into these databases, they have very powerful hardware as the hardware improves, and so they can crack these hashes. Back when I started web development, things like MD5 was the de facto. It was the golden standard. Now we're looking at other things like bcrypt and the SHAs and all of that stuff. And obviously, the longer the hash, the more complicated the hash, the more hardware it takes to compute that. So over time, these hashes need to be improved. They need to be strengthened. They need to be more complex throughout the years. If, for example, you had a website, say 2 years ago, 5 years ago, for instance, and that was using MD5, well, that's not going to be as secure today as it was 5 years ago, simply because the hardware these days has improved. So how do you go from a 5-year-old hashing algorithm to the latest gold standard? How do you move, for example, from MD5 to bcrypt? Now, there is a number of ways you can do this. Some are quite intrusive to the user, to the customer, and some can be done in the background. I prefer doing the ones in the background, but let's talk about the ones that impact the user. So one way is to obviously get them to change their passwords. So that's requesting them to alter their passwords, renew their password. You could do that perhaps using an expiry against their password. Send them an email with a reactivation link. But now that's quite intrusive. You are basically forcing them to do something in order to continue with their service, and that would bring perhaps some questions over whether or not that company has been compromised or not. You know, why are you telling me to change your password? That's not, in my opinion, the best way to go. Another way, of course, is to do it as they log in. So, for example, if they've logged in correctly with their correct older hashed password, is to then rehash that in another hashing algorithm. That's done without, in the background, the user isn't really affected. The problem with that, though, is that you have some passwords that are used against old hashing algorithms and new hashing algorithms. So you can't really say how many users have gone through that chain unless you were to record that. And that is itself another issue, because you're recording how strong a password is or what version of the algorithm was used in the database. If your database was compromised, for example, then the person, the attacker, the hacker, would have that knowledge. So he would know that there are different versions of passwords and so forth. Some would be more secure than others. So in my opinion, that's not a good idea. Try and keep your database from giving too much away if it was to be compromised. So another way you can do it is just to rehash everything in one go. So for example, if you were using MD5 before, you can then rehash that into, say, bcrypt. That means that everybody is now on the same level playing field. And with bcrypt, you can supply a cost, and that cost determines how complex the hash is, how long that hash is, and you can change that throughout the time. So, for example, if you were to install a load of RAM in your database or wherever the password's going to be encoded, you can improve that as time goes on. So you end up basically with a bcrypt, and then that bcrypt has a hash of an MD5 hash, for example, and so you check the bcrypt, then you check the MD5 hash. And there are companies out there that do odd things with, say, putting in prefixes and suffixes, so you can then check those too. But basically, it's kind of like a very progressive thing with passwords and hashes. Do not expect that the hash that you use, say, 5 years ago to be as good now as it was then. There are tools, there are certain programming methods to analyze the length and complexity of a hash and then flag it up to be rehashed if it doesn't meet the golden standard that you're setting. Another thing that I would suggest is where you store your passwords and your user data. Now, I've done work with, say, MongoDB, DynamoDB, Elasticsearch, and all sorts of stuff like that. So different data stores. Now, I strongly advise to store your passwords in perhaps a separate data store from those. I certainly don't recommend storing that in Elasticsearch because that's clear text. It's not, it's not supposed to be for security. It's supposed to be for search. Again, MongoDB, it's very easy to alter a document by accident, or it's very flexible. That's the point. These NoSQL databases are extremely flexible, and I found it very beneficial to have something that is inflexible to store user data, so passwords and usernames and stuff like that. So I stick to SQL. I mean, there might be others who use NoSQL for storing passwords and such. I'll be interested to hear from you and to hear your experiences with that. But for me, I kind of want something that is a little bit more structured, a bit more relational, something that is inflexible, cannot be changed easily. Once you've set your password, right? And I don't want that password coming down with all the other documents and being sort of related like that. If that's in a separate table on its own little world, then that's fine. In fact, I do know of companies that have passwords stored completely separately from everything else, and that is such a, that decoupling is so good. So you have a passwords table and you have a users table, and you might have that passwords table sat on another database, sat on another server somewhere, which is properly secured down, locked down, and so forth. So, I mean, that I would highly recommend looking at that. If you're changing the way that you're storing passwords, then also look at where you're storing your passwords, how you're storing your passwords, and so forth. Anyway, I'm going to leave it there. I know it's been a bit of a quick video and I've gone through a lot of stuff, but if you've got any comments or questions or queries, do put them down in the comment section below. Like the video if you found it helpful, and remember to subscribe to pick up the web chats as well as the tutorials that I publish every week. Thanks again, happy coding. I will see you again next week. Cheers, bye.